Welcome to Naradar Academy. In this video, I am going to discuss about Gauss divergence theorem in vector calculus. Divergence theorem give the relation between surface and volume integral. So for that, I am considering a closed surface S enclosing a volume V. Okay, for example, if you take sphere, S denote the surface of the sphere and V denotes its volume. Okay, so this S denotes the surface of any closed surface and V is the volume enclosed by it, and this A vector is a vector valued function defined on S. Then what are we doing here? A dot ds means ds stands for small elementary area. S for the full surface, ds means what? Elementary area. A dot ds give you the value of this vector valued function in a small elemental area. Integration means what? Summing up. So summing up the vector valued function's value throughout the surface. This is what the left hand side. For calculating this, instead of using this double integral, we can use triple integral. So on the right hand side what we have, triple integral over V del dot A dV. Del dot A is nothing but divergence of A. So if you want to calculate the value of this vector valued function A throughout the surface S, instead of doing this double integral, it is easy to find its value by using this. That is triple integral over V del dot A into dV. So this is the statement of Gauss divergence theorem. Now I am going to discuss a few problems where we are using Gauss divergence theorem. This is the first problem. Evaluate double integral over S r vector dot ds where S is the sphere, x square plus y square plus z square equal to 9. Okay, so by looking at this double integral, you have to identify this can be evaluated by using divergence theorem. Okay, so what is the statement of divergence theorem? Double integral over S r vector dot ds is equal to triple integral over V del dot r dv. So this is the divergence theorem. So I have to evaluate this. Instead of evaluating the left hand side, I am going to find only the right hand side. Okay, so for that we have to find what is del dot r. Already in a previous video I told you that r denote the position vector xi plus yj plus zk. So what is del dot r? Del dot r is obtained by del dot r is nothing but what? Divergence. Divergence means how to calculate, differentiate the I component with respect to x plus j component with respect to y plus k component with respect to z. Okay, so differentiate this with respect to x. So dou x by dou x plus dou y by dou y plus dou z by dou z. So 1 plus 1 plus 1. So del dot r equal to what? 3. So we have evaluated this del dot r. So let us substitute in this statement. Okay, so what will you get? Double integral over r. Double integral over S r dot ds is equal to triple integral. Instead of del dot r, I can substitute 3 into dv. Okay, so 3 into triple integral over v dv. Okay, integrating this, you will get volume of the given surface. Okay, triple integral over v dv means volume of the given surface. What is the surface given here? Sphere, isn't it? Look at the question. S is the sphere, x square plus y square plus z square equal to 9. So this integral is nothing but volume of the sphere, x square plus y square plus z square equal to 9. From this equation, this is 9, no? This 9 is nothing but what? 3 square. So radius of the sphere is 3. Okay. X square plus y square plus z square equal to a square is the standard equation of a sphere. So here it is 9, that means 3 square, that 3 is the radius of the sphere. So volume of the sphere I have to substitute. So 3 into, what is the volume of the sphere? 4 by 3 pi r cube. Here the radius is 3. So 4 by 3 into pi into 3 cube. So simplification gives you 108 pi. So this is the value of double integral over S r dot ds over the given sphere. One more problem we will see. See, this is the next problem. Evaluate double integral over S r dot ds where S is the cube bounded by x equal to minus 1, x equal to plus 1, y equal to minus 1 and y equal to 1, z equal to minus 1 and z equal to 1. So this is the given solid. Okay, so one is x, if this is x equal to minus 1, this will be x equal to plus 1. If this is y equal to minus 1, this will be what, y equal to plus 1. And similarly, if this is z equal to 1, and this will be z equal to minus 1. That's all. So over this cube we have to evaluate. So again we are going to use divergence theorem. So by divergence theorem, double integral over s r dot ds is equal to triple integral over v del dot r dv. So del dot r already we find in the previous problem, it's equal to 3. So 3 into dv. So 3 into, what is triple integral dv? Triple integral dv is nothing but volume of the given surface. What is the surface given here? Cube. So volume of the cube. So volume of the cube is nothing but length into breadth into height. So how to find the length, breadth and height? So length is nothing but, suppose if you take x is along the length, then this is lower limit, this is upper limit. The length is given by upper limit minus lower limit. So 1 minus of minus 1 equal to what? 1 plus 1, 2. And similarly, if this is taken as breadth, so breadth equal to upper limit minus lower limit. So 1 plus 1 equal to 2. So height is given by z. So upper limit minus lower limit. So if any figure bounded by straight lines is given, you can find the length and breadth using the formula upper limit minus lower limit. That's all. So here this cube contains length 2 unit, breadth 2 unit and height 2 units. So the volume is L into B into H. 2 into 2 into 2. So 8 3s are 24. So the final answer is 24. And this is another problem. Find the value of double integral over s a vector dot ds where a equal to 4xzi minus y square j plus yzk. And s is the surface of the cube bounded by x equal to 0 and 1, y equal to 0 and 1, z equal to 0 and 1. So this is a cube. We are going to evaluate this integral by using Gauss divergence theorem. So what is the divergence theorem? Double integral over s a dot ds is equal to triple integral over v del dot a dv. So first let's find what is del dot a. That is divergence of a. Divergence of a is obtained by differentiating I component with respect to x, differentiating j component with respect to y, plus differentiating k component with respect to z. Okay, so what we get? Dou by dou x of 4xz. So differentiate this with respect to x, it is 4z. Differentiate this with respect to y, minus 2y. Differentiate with respect to z, so it is plus y. So 4z minus 2y plus y, so it's equal to 4z minus y. So double integral over s a dot ds is equal to triple integral over v 4z minus y into dv. Now we have to evaluate this integral. So for that, here two terms are there, no? So let us write it as two different integrals. Triple integral over v 4z dv minus triple integral over v y dv. Okay, now here this 4 is a constant, we can take it outside. So triple integral z dv is there, no? This is nothing but, dv means volume, so v we can write, this is nothing but the center of mass. Okay, that is center of mass of the cube, and since it is z, no, it is z bar. That means z bar is the z coordinate of center of mass of the given cube. Similarly, y dv means, here we have dv, no, so v into y bar. What is this y bar? Y bar is the y coordinate of the center of mass of the given cube. Okay, this is a simple trick that you can follow here. If it is not possible, you have to integrate this by using the limits. That also you can do, otherwise you can do in this way. This is a very simple one only. So here we have to, what we have to find here? Center of mass of the given cube. Okay, center of mass will always lie in the center of the solid only, because most of the solids given here will be uniform solids only. So center will always at the center of the given solid. So here x equal to 0, x equal to 1. So what is the center of this line? At 1 by 2, no? So 1 by 2. Here y equal to 0, y equal to 1. What is the center? 1 by 2. So 1 by 2. Z equal to 0, Z equal to 1. The center is 1 by 2. So the center of mass of the given cube is at 1 by 2, comma 1 by 2, comma 1 by 2. So x bar equal to 1 by 2, y bar equal to 1 by 2 and z bar equal to 1 by 2. And here what is we have? V. V is the volume of the given solid. The given solid is Q. So volume is equal to length into breadth into height. So for this solid, both length, breadth, height, everything is equal to 1. Because x varies from 0 to 1, no? Okay. So 1 into 1 into 1. So volume is equal to 1. Let us substitute this y bar, z bar and volume V in this equation number 1. So what will you get? Double integral over S a vector dot ds is equal to 4 into volume is 1 into z bar is half minus volume V is 1 into 1 by 2. So this is 2 minus 1 by 2. It's equal to 3 by 2. That's all. This is another problem. Evaluate double integral over S a vector dot ds where a is 4x I cap minus 2y square j cap plus z square k cap taken over the cylindrical region bounded by x square plus y square equal to 4, z equal to 0, z equal to 3. See, this is the equation of a cylinder where this one x square plus y square equal to 4, you know, that represents a circle with radius 2 units. Here it is 4, no, that 4 you have to write it as 2 square. So this is a circle of radius 2. So this is the base of the cylinder. The base of the cylinder is always a circle, no. So this is the circle x square plus y square plus x square plus y square equal to 2 square. So it is of radius 2. And this z equal to 0 and z equal to 3 will give you the beginning and ending of the cylinder. So z equal to 0 means it is the XOY plane. It is the cylinder base is at the XOY plane and the cylinder extends up to z equal to 3. So this is the point z equal to 3. So the cylinder is along the z axis like this. Okay. So now let's evaluate the integral. By divergence theorem, double integral over S a dot ds is equal to triple integral over V del dot a into dv. So let's find the divergence. Divergence of a is equal to dou by dou x of the I component 4x plus dou by dou y of the j component minus 2y square plus dou by dou z of the k component z square. So differentiating this, we are getting this value. Let us substitute it here. So double integral over S a dot ds is equal to 4 minus 4y plus 2z into dv. As in the previous problem, since there are 3 terms, no, let us write them as 3 different integrals. 4 into triple integral dv minus 4 into triple integral y dv plus 2 into triple integral z dv. Now, triple integral dv is nothing but volume. Okay, so this is simply 4 into volume of the given solid minus this is y dv, no, this y dv is nothing but y bar into v, where y bar is the y coordinate of the center of mass, plus 2 into this triple integral z dv is nothing but z bar into dv. Z bar is the z coordinate of the center of mass. So now let's find the volume of the given cylinder. Volume of the cylinder formula is pi r square h, where r is the radius of the base. Base, here the circle is there, no, that's radius is r and h is the height of the cylinder. So the base radius is given by this equation, x square plus y square equal to 4, no, this 4 is nothing but 2 square. So the radius is 2. So pi into 2 square into this h is the height of the cylinder. Already I told you the cylinder starting from z equal to 0 and it extends up to z equal to 3. So the height is 3. So this value is 4 3s are 12 pi. So the volume of the given cylinder is 12 pi, that we can substitute it here. Next one is we want to find the center of mass. Already I told you the center of mass of any uniform solid always lies in the center. So here the cylinder is like this, no, it is along the z axis. It starts from z equal to 0. This is the point z equal to 0 and this is the point z equal to 3. So this will be the midpoint. Here I have marked, no, this will be the midpoint. That is where the center of mass lies. So on z axis, x value 0 and y value 0. And the z value is, here this is from 0 to 3, no. So the midpoint will be what? 3 by 2. Okay. So this is, since this is along the z axis, x and y coordinates are 0, z coordinate is midpoint of the 0 and 3. What is the midpoint of 0 and 3? 3 by 2. So the center of mass is given by 0, 0, 3 by 2. That means x bar is 0, y bar is 0, z bar is 3 by 2. Let's substitute this x bar, y bar, z bar and the volume in the equation number 1. So we get double integral over s a dot ds is equal to 4v. So 4 into volume is 12 pi minus 4 y bar is 0. So this term will become 0 plus 2 z bar. 2 into z bar is 3 by 2 into volume is 12 pi. So finally this is 48 pi plus this is 36 pi. So it's equal to 84 pi. The value of this integral is equal to 84 pi. The last problem of this video, evaluate double integral over s a dot n cap ds where a equal to 2xz I cap plus yz j cap plus z square k cap for the region bounded by the upper half of the sphere x square plus y square plus z square equal to a square and the plane z equal to 0. So here this equation denotes a sphere with radius a. Okay, but the whole sphere is not given here. Only one part of the sphere, upper half of the sphere is given. Okay, so this is the diagram. So this is the sphere and it is bounded by one line, one plane they have given, no, z equal to 0. This is xy plane. So the sphere will be like this. The base is on the xy plane and it will be lying like this. Okay. So as usual, by divergence theorem, the given integral, the required integral is equal to del dot a dv. So del dot a divergence is nothing but differentiation of I component with respect to x plus differentiation of j component with respect to y plus differentiation of k component with respect to z. So we get it as 5z. Now substitute it here. Triple integral over v 5z dv. So 5 into this integral is nothing but z bar v. What is this z bar? The z coordinate of the center of mass and v is the volume of the hemisphere. Volume of the sphere is 4 by 3 pi r cube. Since this is a hemisphere, only half of the sphere, no? So it is 2 by 3 pi r cube. Okay, so the radius of this sphere is a, that is given in the question itself. See, x square plus y square plus z square equal to a square. So the hemisphere volume is 2 by 3 pi a cube. And center of mass, this is a hemisphere, no? So the center of mass will be lying somewhere here. So on the z axis, I told you x value, y value will be 0 only. So 0, 0 and this is 3a by 8. There is a very big calculation for finding this center of mass of hemisphere. So as of now, just you remember this 3a by 8 is the center of mass for a hemisphere. Okay. Since this is a hemisphere, this is something different. Okay, if it is a full sphere, it will be exactly at the center of the sphere. Since this is a hemisphere and this is not uniform, you see, here it is a full circle, here it is going like this, no? So we have to do the calculation for that. So you remember the center of mass of a hemisphere is given by 0, 0, 3a by 8. Okay, so x bar 0, y bar 0, z bar is 3a by 8. Let's substitute this volume and z bar here in equation 1. So what will you get? 5 into 3a by 8 into 2 by 3 pi a cube. So the answer is 5 pi a power 4 by 4. That's all. Thank you.